Okay, so here's a question, a quadratic function, and I want to get some characteristics of it. So say I want to get, let's get x-intercepts, y-intercepts, let's get a vertex, let's get an axis of symmetry, let's get a maximum or a minimum value. Let's get a direction of opening, and let's determine the domain of the function and the range. All right, so first off with x-intercepts, I'm going to let f of x equals 0, and then I'm going to solve that equation. So f of x is y, right? So I want to find all the places where y is equal to 0, and that's anywhere along this x-axis. Okay, so it's going to be a parabola that's going to come and swoop down, something like that. And so finding the x-intercepts are finding those spots right there. Okay, so first thing I would do is try and factor it. So x and x, I'm thinking 10 and 4, minus 10 and plus 4. Is that right? Yeah, that's right. Equals 0. So I can use the 0 property now to solve for the x-intercepts. So either x is a minus 4 or x is a positive 10. So that point there would be negative 4 and 0, and that point there would be 10 and 0. Okay, so those are my x-intercepts. They're negative 4, 0, and 10, 0. And again, I could graph that on decimals to see where those are. The y-intercept is always this constant term, or I could say it's the value of the function when you plug a 0 in everywhere you see an x. So if I do that, this is 0, this is 0, so 0 is negative 40. So the y-intercept would be 0 and negative 40. Okay, now to determine the vertex, I can use complete the square to do that, or I can use the formula. I'll show both. So this is my function, and I'm going to complete the square. So I'm going to factor out an x, I'm going to group those two. So x squared minus 6x minus 40. And then to complete the square, I take this 6 and divide it by 2, and then I square it. So 6 divided by 2 is 3, negative 3 squared is a positive 9. So this is a positive 9, and so out here I'm going to subtract 9. So if I factor this, it'll be x minus 3 times x minus 3 minus 49, or x minus 3 squared minus 49. So the vertex will be 3 and minus 49. Notice I changed the first sign, but not the second. So my axis of symmetry is x is equal to 3. Since this is positive, then that means the graph opens upward like this, meaning that there has to be a minimum value. So I'm going to have a minimum value, and the y value that's going to be the minimum is negative 40. Okay? So there's a minimum value of y is equal to negative 40. Not 40, negative 49. I was looking at this number, but I should have been looking at this number. Okay, domain refers to x's. So I can say that my domain are all the x's, and any x is allowed. I can go as far left or as far right with this graph as I want. And so the x's would be all the x's as long as x is an element of the real numbers. Another way of saying that with set notation is negative infinity to positive infinity, and everything in between. Now range refers to y values. And so I can say my range is all the y's as long as, now y's is up and down, right? But these y's down here don't count because they're not on my graph. My graph is this right here. And so these ones down here don't count. So it's only the ones from whatever the vertex is up. So my vertex is at negative 49. So my range are all the y's as long as y is greater than or equal to negative 49. Okay, another way of doing that in set notation is you'd say your smallest number, which can be included, is negative 49, and your highest number is positive infinity. Okay, just the last thing I wanted to do was to show you how you can determine the vertex and basically all of this stuff in there using a formula. So if my function is this, x squared minus 6x minus 40, I can do this stuff right here, and from that I get my vertex. Or I can use a formula, and the formula is this. So to get the x coordinate of your vertex, just go minus b over 2a. And then to get the y coordinate of your vertex, find the value of the function when you plug that number in, wherever you see an x. Okay, so let me show you how to do that. So the x coordinate of the vertex, minus b over 2a. So minus, I should have a comma there, sorry. Minus b over 2 times whatever a is. B is a negative 6, right there. And a is the number out front, which is a 1. So negative 6 would be a positive 6 over 2, which is 3. And that's the same as I got doing it the other way. Then to find the y coordinate of the vertex, I figure out what f of 3 is. So here's my function. I'm going to plug in a 3. So it's x squared minus 6 times x minus 40. So I'm plugging in a 3 everywhere I see an x. So 3 squared is 9. Minus 6 times 3 is a minus 18. Minus 40. So if I subtract all that stuff, I think that comes out to minus 49. And that's what I got doing it the other way. So using this formula is just an additional way you can find the vertex other than completing the square.